Hello friends, Mr. Burrell here. We're nearing the end of our first review unit. We've talked about several things. We've talked about solving equations. We've talked about solving several different kinds of equations. We've talked about the difference between solving, simplifying, and evaluating different math expressions. We've talked about the order of operations. And on the subject of solving equations, today we're going to talk about creating equations. Now that we know how to solve them, we're going to talk about some situations where we might need to create an equation, a mathematical equation, to represent some sort of situation. So by the end of the lesson today, this is what I hope you're able to do. Create mathematical equations from story problems. I don't love that terminology, but from like word story problems, we're going to create mathematical equations to model those kinds of problems. So, first question, I have kind of a scenario for you to ponder. So Mr. J is twice as old as his son, and together their ages add up to 60 years. How old is Mr. J, and how old is his son? So I want you to think about that. Think about how old Mr. J is. Think about how old his son is, and think about how you'd be able to find that out. So right off the bat, lots of people, usually when I give this problem, lots of people are like, oh, well, Mr. J is 40 and his son is 20, because Mr. J has to be double the age of his son, and they have to add up to a total of 60 years. That's correct. So, before I knew that Mr. J's son was 20 years old, I can use a variable, some variable, I'll use x here, to represent the son's age. I don't know how old he is yet, so I'm going to represent it with x. And I know that Mr. J, so if this is the son, I know that Mr. J is twice that age, or double that. 2 times x is 2x. Okay? Then added together, when I add both of their ages together, it has to add up to 60 years. They have to total up to 60 years. Well, this, 2x plus x equals 60, this is an equation that I can solve. On this side, I'm going to simplify and combine my x's together to get 3x equals 60. And then to solve for x, I'm going to go ahead and divide by 3 on both sides, which gives me x equals 20. X, the age of the son, is 20 years. 2x, or double that, is 40 years. So I was able to create this math equation and solve it to determine how old Mr. J and his son were. So, as far as finding out their ages, a lot of us were able to do it without the equation. This was kind of a relatively simple example. Oftentimes, it's not going to be that simple. Oftentimes, a mathematical equation is easier to use to solve a problem like this. So could we use an equation to represent their ages? Yes, we just kind of went through that. And then we reviewed this a little bit the other day, but a variable, remember when I say a variable is some letter, I usually use letters, to denote a value that I don't know yet. So I didn't know how old Mr. J's son was, so I use a variable to represent that value until I'm able to find it. Okay, so some words to generally look out for when we're writing these different equations and identifying these different situations. Some things to remember, some math terminology you might come in contact with. When you see the word sum, I'm talking about like addition. When you see the word difference, we're talking about subtraction. When you see the word quotient, we're talking about like division or like a fraction of some sort. The product, we're talking about multiplication, either like multiplying by something in parentheses or just multiplying by something. Then when I say something is the same or if things are like equivalent to each other, I'm usually talking about things being equal. So those are some math terminology associated with some of these different operations that we know about: addition, subtraction, division, multiplication, etc. So, for example, I have some sentences, and I want you to write these as an equation. So, for example, this one says, the sum of 8 multiplied by a number, comma, and 7. So, 8 multiplied by a number x, that's going to be 8x. The sum of that and 7, sum is talking about addition, so I can write that as 8x plus 7. This is the sum, or the addition, of 8 multiplied by number x and 7. Okay. The second one, the difference between 19, comma, and 3 divided by a number y. So the difference between 19, difference is subtraction, the difference between 19 and 3 divided by a number y. Or the difference between 19 and 3 divided by a number y. You could write it either of those ways. So I'm just writing these expressions in like math terminology. The product, that's multiplication, of a number x divided by 2 and a number x divided by 4. So I have a number x divided by 2, which would look like this. I'm doing the product, so I'm multiplying by a number x divided by 4. So I'll skip that last one, but this is what we're doing. This is what part of our assignment is going to be on. If I were to say these out in English words, how would you write them in math terms? Same thing here. I'm doing the same thing. So here I'm going in reverse. I'm going to give you the equations. I want you to write it out in like English words. So here, this is 7 plus x divided by 3. I could literally write my statement that way. So I could write 7 plus x divided by 3. That's not the only way you could write that statement, but that's one of them. 7 plus x divided by 3. The second one here is 12 over x plus 4, or 12 divided by x plus 4. So I could literally write 12 divided by x plus 4. Or I could say the quotient. Instead of like saying divide, I could say the quotient of 12 and x plus 4. So like this one right here, I could say x divided by 6 added to the product, because I'm multiplying over here, the product of x and 1 plus x. So basically what we're trying to do is we're trying to describe in English words what each of these statements are. Okay? So that's the general idea. Now we're going to talk about some like real world story problem kind of scenarios that we're going to try to create equations for. So we saw this one the other day. I told you we'd come back to this, right? So the state fair offers a discount for group admission. I talked about this in relation to myself. A group of 25 kids purchased 25 passes and 25 concert tickets. Each concert ticket costs $15. The total cost of the admission is $512.50. Find the cost of each pass. Okay. So they needed to buy 25 passes and 25 concert tickets. Okay. Well, I'm told that the concert tickets are $15. So the concert tickets are $15. But I don't know the cost of the passes. I don't know the cost of the passes. Well, what do I use to denote a value that I don't know yet? I use a variable. Let's go ahead and use P for passes. I don't know how much the passes cost, so I'm going to use P to represent the passes. So I have 25 passes at some dollar amount. I don't know how much. I need to add the cost of the concert tickets, which is 25 times $15. 25 times 15, I have my handy-dandy calculator here, is $375. And those added up needs to be $512.50. Those added together need to add up to the total cost of admission, which is $512.50. There's some of the questions on your homework where this is all you have to do. Just set up the equation. Now that I have this equation set up, could I solve for the price of the passes? Yes, I could solve for P. I'll go ahead and subtract 375 on both sides, which would give me 25P equals, what's 512.50 minus 375? 137.50. Then I'm going to go ahead and divide by 25. If I divide that by 25, I get P equals 5.5. Or in other words, each of the passes costs $5.50. Each of those passes cost $5.50. Okay, let's look at another example. I have a dilemma. At the back of my classroom, I've been wanting to put another whiteboard on my back wall. Occasionally, the school gets whiteboards from like USU, whiteboards that they're not going to use anymore, and I've been wanting to put one on my back wall. But I have some criteria I want to meet. I want the length of my whiteboard to be double the height. That's about what the whiteboards at the front of my classroom are, so I want them to be about the same. I want the length to be double the height. And I want 32 square feet of writing space. I want quite a bit of writing space because I want to put some stuff on that whiteboard on the back wall, right? Okay, so this says, write an equation to describe this situation and then determine what the dimensions of my whiteboard need to be. So, this is my whiteboard. I want the area to be 32 square feet. I want the area of this whiteboard to be 32 square feet. And I want the length to be double the height. So if this is the height, I want the length here to be double that. So 2h. Double the height. Okay. Well, how do I find the area of a rectangle? My whiteboard's going to be a rectangle. How do I find the area of a rectangle? Well, the area of a rectangle is equal to base times height, or length times width, or one side times the other side. So the area of this whiteboard, this rectangle, is 32 feet squared, and that area needs to be equal to the base, which is 2h, times the height, which is just h. Okay? So that's my equation. Again, some of the problems on your homework, that's all you have to do. Now, let's see if I can solve for what the height needs to be. So 32 equals 2, h times h is h squared. So I'm going to go ahead and divide by 2 on both sides, which gives me h squared equals 16. How do I undo squaring something? I square root. That cancels out the squared here. The square root of 16 is 4. So the height of my board here, the height of my whiteboard needs to be 4 feet, and the width, the base of my whiteboard needs to be double that, which is 8 feet. So my whiteboard needs to be about 4 by 8 feet. 4 feet tall, 8 feet wide. Okay, so those are a few examples. We're going to go over a couple off of the homework right now. But that's what we're doing. We're creating mathematical equations from story problems or from words. So hopefully you can kind of self-assess yourself. Hopefully you're feeling pretty good about this. We're going to do some more examples. I'm going to exit out of here real quick. And we're going to, let me close out of that business. We're going to go ahead and pull up the assignment right here. We're going to go ahead and zoom in here. Okay. So first of all, let's do one up here. So on the assignment, if I look, say, at number 3, this is the 1.5 assignment. Number 3 says the difference, first the instructions say, write the following statements as mathematical expressions. This says the difference of 7 times the number x and the quotient of that number x and 3. So difference is subtraction. I'm subtracting two things. The first thing is 7 times the number x, 7x. And the second thing is the quotient of the number x and 3. So the quotient is division. So I'm taking the difference of 7x and x divided by 3. So that right there would be my expression, my math equation. Okay, so that's what we're doing on questions 1 through 3. On questions like 4 through 6, we're going backwards. I have the equation and I'm going to write the expression. So like this is 5 plus 1/2 times x, so I'm just going to literally write 5. I'll write multiplied, added to, wow, this is adding, good grief, 5 added to 1/2 multiplied by x. 5 added to 1/2 multiplied by x. Okay, sweet. So now let's look at a couple of these story-esque type problems. I have some situations that we're going to write some questions for. So question number 7, for example, says Caden earns a $40,000 salary plus a commission of $300 for every machine he sells. So he makes $40,000 a year, and then he makes an additional $300 every time he sells a machine. And he wants to earn a total of $100,000. So how many machines does he need to sell? I don't know how many machines yet he needs to sell, so I need a variable to represent that number of machines. Let's use M for machines. We'll use M to represent the number of machines. So he makes $40,000, and he will make an additional, so I'm adding $300 for every machine he sells. So $300 times M, that will tell me how many dollars he makes from the machines. And this all needs to add up to equal $100,000. So, how many machines does he need to sell? Well, in order to solve this, I need to get M by itself. So I'm going to go ahead, I need to get rid of this 40,000. So I'm going to subtract 40,000 on both sides, which gives me 300M equals 60,000. Since I have 300 times M, I'm going to divide by 300 on both sides, because that'll cancel these out. And 60,000 divided by 300, if I calculate that out, I get M equals 200. So to reach his goal of making $100,000, Caden is going to need to sell 200 extra machines on top of his regular salary. He's going to need to sell 200 machines to make that extra money. Okay, let's do one more. Let's choose one more here. Ooh, I like this one. This one I'm not solving. I'm just going to write the equation. So number 13 says the length of a photograph is 1 centimeter less than twice the width. I should say is. The length of a photograph is 1 centimeter less than twice the width, and the area is 45 centimeters. So I have a photograph here. Here's some people in the photograph being really happy about just life and liberty and the pursuit of happiness. It says the area of this photograph is 45 centimeters squared, and the length, this length right here, is 1 centimeter less than twice the width. Okay, so here's the width of the photograph. And the length of this photograph is 1 centimeter less than twice the width. So twice the width, and then I need to take 1 centimeter less than that. So the length I can write as 2W minus 1. The width I write with W. The length is double that minus 1 centimeter. So that means the area, again, area is equal to length times width. Area of a rectangle, this rectangular photograph is length times width. And the area we were told was 45 centimeters squared. So 45 is equal to the length, which we determined was 2W minus 1. I'm going to write that in parentheses. The length is 2W minus 1 multiplied by the width, which is W. So this one doesn't require me to solve. So later on in Math 2, we talk about how we're going to be able to solve equations like this. But I have 45 equals 2W minus 1, in parentheses, multiplied by W. So that's what we're doing. That's what we're doing in this assignment. We're creating equations based on these story type problems. So I hope that was helpful. If you have any questions, please don't hesitate to reach out and let me know. And I hope you enjoyed that as much as I did.